Hello and welcome to another edition of Tech Launch in the News. Let's get into it. Web 5 versus Web 3. We're going to start with that today. This is basically a definition of what these are, but conversation around what Web 5 and Web 4 are in addition to Web 3. So diving right in, you can see this picture of Web 1, Web 2, and Web 3 as they're generally defined. So Web 3 being decentralized web, private and secure, user-centric. But then you can go and dig in and see that as you look at Web 3 and some of what it is meant to do, basically this capability of decentralizing, not controlled by any one entity, informed by platforms that use consensus mechanisms that everyone can trust. Then you get into some of the other major issues and then proposals essentially for Web 4 and Web 5. So a lot of critics validly have expressed concerns about Web 3. It has a lot of dependence on venture capitalists. We've talked about that in previous in the news. And it would compromise its main focus of innovation, having all of this very myopic funding that's driving it. One of the interesting concepts is Web 4, which is also known as mobile web. And this is essentially that it's going to be a mobile environment and all of the necessary infrastructure for that. Essentially, imagine a web that connects all mobile devices in the real and virtual world in real time. So it enables mobility and voice interaction between the user and robots and essentially expands the reach of the web into the real world and into more of our standard interactions as opposed to through keyboards, mouse, that kind of a thing. But there was a proposal for Web 5 that came out, and you can see that Jack Dorsey is driving this. He's making a controversial statement, which basically says rip Web3 VCs. And you can see this concept here that's happening, this undercurrent of getting away from the VCs that have this very myopic pull on this Web3 decentralization. And so Jack Dorsey is essentially saying, we're going a different direction. We're actually going to do what was intended with Web3 with Web 5, essentially. Now, originally, the phrase Web 5 came out in a 2009 TED Talk from the literal founder of the internet, where he described it as a emotional web. So the true form of Web 5 is still forming, but according to what folks have heard and said in this type of context, it's a symbiotic web, and it will be an interconnected network that communicates with us as we communicate with each other. So like a personal assistant. So you can see the same concepts developing with Web 4 and Web 5, where it's this very interconnected, intelligent, and the word symbiotic is a great word, web. Jack Dorsey's definition, if you take a look at it, is a little bit different. He's basically saying, instead of doing this more extensive symbiotic relationship of Web 5, where you would have like users interacting with content and then actually having facial recognition, identify their emotions, and possibly change what content they get based on their emotions, how comfortable they are with it, and really basically reading people's minds to some extent. He had more of a mechanical definition, at least implied, with some of his presentation at TBD. And specifically what he said was the internet's main problem is the lack of an identity layer. In the current web, identity and personal data are turned into the property of third parties. Now, make sure you really get that, because that's essentially the crux of the matter here. Identity and personal data are turned into the property of third parties. And that is so true. If you've done application development, you know that this is the case. And it, in most cases, is something that is sensitive and a concern for those companies. They don't necessarily want to have to store it. They also do have access to it, and it creates an ethical problem in some cases with marketing and advertising at minimum. This is why Web 5 will focus on decentralizing identity, data storage, as well as its applications. So the concept here that he's presenting is less of a symbiotic web and just more of what Web3 is really intended to do in the first place. So it's interesting. The main point here, though, is that you're seeing this undercurrent of moving toward a symbiotic web as it continues to develop. And you look at the next arena or the next major push beyond Web3 itself, it's going to be toward this very interesting development where there's more interaction that's more seamless and almost like an augmented reality type of experience mixed with a truly immersive interaction with the internet and with other devices that extend the internet into the real world. And Web3 itself is going to have to deliver on this promise, whether we call it Web5 or Web3, it's going to have to deliver on this promise to actually decentralize everything. That is the crux of what Web3 and, as Jack Dorsey is calling it, Web5 have to deliver on. So it's kind of interesting if you hear those terms mentioned. Hopefully that helps you to understand what some folks are saying and what they're meaning, and what the root of those are. Okay, so this next article is going into security. Now, we've talked about this quite a bit in the news for this area with Web3. Is one of the biggest Achilles heel of this really overall Web3 space and crypto and blockchain being able to take over has to do with the security side of things. So it's really naturally important that this be a solution that we can get to that is viable mechanically. One of the things that you see whenever you look at Web3 is there's a lot of promise with blockchain, but there was a lot of necessary iteration on executing at scale. So whenever you go to transact with Bitcoin, for example, well, it actually requires so much compute, even for Ethereum, one of the next additions and developments, that effectively you have these additional chains that were developed and approaches to being able to process the security side of the transactions, that you have Solana and other formats like this that came out to be more efficient. Now, ultimately, one of the big things with the security is this idea of zero knowledge proofs. And if you haven't heard of this before, basically the idea is that they are utilized to improve the functionality of blockchain. It was actually developed 40 years before the advent of the decentralized ledger. So basically, it was presented in the 1980s as a concept. And there are basically two types of zero knowledge proofs. And the idea here is to dramatically improve the security of these blockchain interactions so that you don't have the big security issues that we've been seeing recently. Over $10 billion lost in the crypto space alone, for example, that we know of. Interactive zero knowledge proofs, and these require the prover to carry out a set of tasks or actions to demonstrate that the verifier that they have specific information. So the majority of these involve some aspect of mathematical probability. So you're basically taking information that you should already have, and you can almost think of like a SSL handshake. And I know this is an oversimplification, but conceptually, you already have a private key. Another example might be looking at a scenario where you already have security questions that you have the answer to that you defined up front when you establish that relationship. So ideally, you're going to be providing something that demonstrates to the verifier that you have the specific information. Non-interactive zero knowledge proofs are really powerful because if you think about it, what they're saying is the interaction between a prover and a verifier can be simulated by the prover, making direct communication to the verifier unnecessary and making proof generation possible to do offline. So that's also pretty interesting. Now, this goes on to basically talk about these three key requirements of completeness, soundness, and zero knowledge. So essentially, the data and personal information of the other party, including its specifics, will be kept unidentified. And this concept can be so powerful when you think about data security and you think about storing information that people have that maybe is PHI or payment card information, other forms of sensitive financial data. There really are a lot of different scenarios where this can immediately apply and take hold and gain a lot of value. As we'll see in this next article, though, one of the interesting things about this is this zero knowledge proof is it's really expensive from a compute perspective. So if you go into this article, it's basically talking about a niche cryptographic technique that could help with this in a lot of use cases. So zero knowledge proofs improve privacy and scalability for some of the most popular blockchains, but they're far from being the only cryptographic method that could accelerate progress in Web3. Full homomorphic encryption, FHE, is even more promising in its potential to bolster privacy in Web3. So it allows for individuals to perform computations on encrypted data without needing to decrypt it. So if you think about that fundamentally, we're basically dramatically reducing the amount of expense in order to get a similar level of value. Expense typically being expressed in compute time and resources necessary to execute on this security. So fully homomorphic encryption is a different kind of privacy technology, and you can think of it as complementary to zero knowledge proofs. Part of the challenge with zero knowledge proofs is that using them can be pricey. And as Ravital Solomon is explaining, she says that many projects built with zero knowledge proofs expect users to have computing power far beyond what the average consumer would have at home in order to perform as intended. Instead of the user needing these crazy machines that are potentially even servers, forget about laptops. Fully homomorphic encryption is much more lightweight than ZKPs for the user. So you can still get the privacy for different kinds of transactions and computations, but you can get it for a reasonable cost, even on a laptop. So this is effectively going into some of the details about her company and some of the projects they're working on. But to summarize, essentially, this idea is that in order for the tech to be useful in the privacy realm, a new layer 1 blockchain is needed, she's suggesting, where essentially fully harmonic encryption is this subset of lattice cryptography. She's also proposing that ZKPs and FHEs on this new layer 1 blockchain would dramatically reduce the cost of being able to do this privacy and encryption. And this is one of the principles that we talk about a lot in this news feed, which is simply that a lot of the principles and the concepts will stay, but some of the implementations are going to rapidly iterate in order to get to a viable solution. And if you look at the compute time, this is absolutely a massive issue. And it's really become prominent in looking at it from a green energy perspective as well, that the actual capability isn't too pricey from an environmental perspective too. My suspicion is that fully homomorphic encryption just recently became efficient enough to make sense for use cases in the last 3 to 4 years, she said. So in order for it to continue to grow, there's going to have to be a lot of investment. Most people don't even know what it is or how it works, but the main idea here is that you don't have to decrypt information in order to get at and use it, which is a really powerful capability. Okay, guys, thanks for watching. That concludes this edition of Web3 in the News. I'll look forward to seeing you in the next one. Thanks for watching this edition of Tech Launch in the News. If you haven't already, feel free to subscribe so you can see more in the news resources. We also have complimentary masterclasses and other resources available to you on our website, www.gotechlaunch.com. If you have any questions or comments, we'd love to hear them in the comments section. And until next time, thanks for watching and bye for now.